Hello, my name's Nathan. I'm one of the builders here at 3612 Ida Bell Lane, and this installment in the video series is all about the insulation strategy that we used here. So I'm going to take a few minutes and explain what we did and kind of how certain details go kind of past what's normal for our area, all with a nod to making sure that this place was the highest performing house we could provide within the affordable context. So let's start by talking about where we insulated and where we didn't, okay? Kind of how we established the conditioned boundaries of the house. And ultimately, it really came down to where we were going to put the heat and air system. It was very important to us here to get that heat and air system to the inside of insulated space so that it could occupy the same conditions that it was providing to the house, right? It just makes sense. Why would you want to air condition by placing the heat and air unit in a hot attic? Why would you want to heat by placing the air conditioning in a cold, drafty crawl space? We wanted it inside the insulation layer. And the way we did that here was by putting it down in the crawl space and enclosing the crawl space to become part of the conditioned zone of the house. That's called a conditioned crawl space. If we had put the air conditioning in the attic, we would definitely have gone for a conditioned attic, but with no air conditioning system in that attic, there's no compelling reason to condition that attic, i.e. bring it to the inside of insulated space. So it remains a hot vented attic, and that's okay, and I'm going to explain why later in the video. The exterior walls and like drywalled surfaces and things, like those are straightforward. You always have to wrap the exterior walls and whatever vaulted ceilings and stuff in insulation. But that's why we decided to put insulation where we did. Let's talk about what we did and what we used. So starting with that crawl space, as I mentioned, that is a conditioned crawl space, and that is different from what you may be familiar with as a conventional crawl space, which has vents in the walls that let air in and out. It has plastic on the ground that's usually just kind of loose laid, and it's got fluffy stuff up in the floor system. That is not what we did here, because you're probably familiar with how those crawl spaces can degrade over time, and particularly because we have our heat and air system down there, we have it sealed off, okay? There's no ventilation to that crawl space to the outdoors. We don't want that air exchange in that way. We want control over that crawl space environment. So it's sealed off from the outside, and it's insulated along the foundation walls, not up here in the floor system, because it's part of the it's included in the conditioned zone of the house. We used a rigid styrofoam product down there that's 2 inches thick, providing a continuous and unbroken layer of R10 insulation for those crawl space walls. And that's, in our opinion, it's perfectly adequate. It's what the building code wants for our climate zone. Those walls just don't have a tremendous temperature difference to contend with, and so we like the R10 for that. We like the rigid foam that we used for a variety of reasons. So it's called Halo Interra, and it is what's known as a graphite polystyrene product. It's basically a lot like the white styrofoam that you may have seen like cheap gas station coolers made from, or like, disposable coffee cups. It's not that grade of foam, okay? It's definitely more robust than that, but it's the same basic chemistry of foam as what that is, but it has a graphite additive which helps its thermal performance in cold weather, which I think is really cool. The other thing that it gives us is a zero thermal drift guarantee. What I basically mean by that is that sometimes other foams can actually lose a certain amount of their R value over time as the little microscopic gas bubbles that they contain lose their gas, and it gets replaced with regular air. And as that happens, the gas and the air that replace it, they have different thermal properties, and so that R value actually goes down. Not the case with the foam that we've got here. It's got that zero thermal drift guarantee because 100% of the off-gassing that it will ever do took place as it was being made at the factory. And so that means that it's completely inert now, it's stable, and I think that's really great. Let's see, that's that. When we were building that area, we actually had to pre-insulate certain little pieces of the floor framing before the big 4x8 sheets for the subfloor decking got laid down over top of it. because otherwise there would have been some places we could not reach later. These trapped inaccessible cavities that we wouldn't have been able to insulate. So we were there alongside the framing crew as they were building this floor system to make sure that we were slipping pieces of insulation in areas we couldn't get to later, so that that crawl space system is perfectly continuous and complete from an insulation standpoint all the way around. Took a little bit of planning, but we did it, no big deal. Let's see. Moving on up, the exterior walls. We have an R19 batt in the exterior walls. That is a lot thicker than what's normal for regular new construction in our area, which is an R13 batt. R13 is what goes between a 2x4 stud. It's 3.5 inches thick. We went with an R19 here, which means that we have a 2x6 wall stud, okay? And the cool thing about that is that when you move to that thicker stud, you can use less studs in the wall, and you're every bit as strong, if not stronger, than that 2x4 wall, even though you have less of the studs that make that wall up. So we have our studs placed on 24-inch spacing, where the default for the 2x4 would have been 16-inch spacing. And you do the math, and that adds up to something like 10% less studs in the wall, which means that 10% more of that wall's overall surface area is occupied by insulation instead. So the 2x6 move helped us in a couple of different ways. It gave us more insulation by share of surface area. It also gave us a thicker insulation, which that R19 is roughly 50-ish% thicker than the R13 batt, and has a proportionate amount additional thermal resistance as well. So it was just a really, really smart way to beef up the thermal performance of our walls. And it honestly didn't really add a ton of cost. It didn't add any extra time to the build. And so it was just an easy no-brainer. You know, why not do that? We made a couple of tweaks to the framing here and there to make sure that we could get insulation in places where you sometimes can't if conventional practices are used. Like for example, the window headers, right? Or the door headers. These are the like mini beams that run across the openings for windows and doors. Well, to make those, you've got to have basically 2 plies of 2x lumber, you know, 2 pieces of it. And when you're building a 2x6 wall, that means that you've only got, you know, 3 inches worth of lumber from front to back. You know, those 2x are 1.5 inches thick. Well, most of the time, headers are built like boxes. And so in a 2x4 wall, it's a little less of an issue because there's just not much choice. You just have to kind of press them together. But because that 2x6 wall is 2 inches thicker, you know, the default for the framing carpenter might be to move one of those pieces of 2x to the outside and one of those 2x to the inside and leave a void in between. Well, if you do that, you can't get insulation inside that void. So we asked our guys to move those together just like they would in a 2x4 wall and leave that cavity space open to the inside of the house so that we could fill it with insulation later. No structural penalty at all, still plenty of attachment for your drywall and everything else, but just a really easy tweak that, again, didn't cost any extra time or money that, you know, gave us that much more thermal resistance in the wall. Similarly, at corners and the intersections where interior walls meet, we had them frame those in such a way that we could get insulation behind that intersecting wall. Many times when you have 2 walls that meet, either in a corner or in an interior wall configuration, the studs are put in a way that creates these little trapped cavities that you simply can't see into, much less push insulation into. So we just changed up the way that we did that. In the corner, we have the studs arranged in what's called a California corner. That allows us to reach all the way back into that corner to the outermost surface and insert insulation back there. Wherever we have an interior wall that has an exterior wall, we instead used horizontal blocking arranged in sort of a ladder configuration to provide attachment for that first stud of the interior wall, which lets us reach back behind there and get insulation into that as well. So a couple little easy tweaks that were just, you know, really easy opportunities to make things as good as we could. Let's see. Now we move up into the vaulted ceiling, fiberglass batts there. The attic is a loose fill blown in fiberglass. And we chose fiberglass here, even though it gets a bad rap in our industry. because we know as professional insulators, sidebar, I have a company called Insulation Unlimited. We are insulation contractors. As professional insulators, we know that the quality of an insulation's performance has more to do with how well it was installed versus what the substance of it actually is. And so fiberglass is super affordable. And we buy a ton of it at Insulation Unlimited, so we can get it at a really, really good price. And we went with that here because it was obtainable very easily, it's very affordable, and we know how to put it in a way that it's going to work to its maximum potential. And it's really not rocket science. You just have to make sure that the cavity's full, there's no voids or gaps, but you also have to make sure that the insulation is not compressed, squished or otherwise crammed. And if you do those two things, the insulation is going to work really great. And so we just made sure to take a lot of care with the install here to provide that outcome. If you go look at other houses under construction that are getting fiberglass jobs, you'll notice how some of the other contractors in our area don't quite take that same level of care. And that's really what gives fiberglass the bad reputation that it has, is not so much that it doesn't work, but more so the haphazard way that it is many times installed is actually what makes it not work very well. And so that association has developed over the years. But I think you'll agree that when you step into this house, you can tell how well insulated it is, and it is all fiberglass from the foundation up. So fiberglass bats in the vaulted ceiling, fiberglass blown in the attic, both to an R38 level. That's the code requirement for ceilings in our climate zone. We feel that it is perfectly adequate. We didn't see the need to increase R value there. A big reason why is just that, every additional R value that you add on top of the last one gets you less and less and less extra thermal resistance. It's a curve of diminishing returns, so to speak. And so once you're at R38, you're kind of at the sweet spot for our climate zone. We don't get very extreme winters here. The heat tolerance is only going to have to go so high. And so that's really where the bang for the buck is. And it helped us get our air conditioning system balanced well to have a known quantity there in that ceiling. And we took the resources that we might otherwise have spent on thicker insulation there, and instead invested that into better air tightness of the house, which arguably impacts the performance of the indoors way more than any extra R value would have. So that's all kind of why we went with what we did. Really, the wall upgrade, it was just one of those things. It's like, well, it doesn't cost any more time or money, so let's do that. But having upgraded the ceilings would have, and so that's why we erred on the side of air tightness rather than more R value there. The blown-in stuff is great because it covers over all of the framing and makes a big continuous blanket up there in the attic space. And one little extra perk that we added in here that you seldom see is out there at the eaves where you have your ventilation baffles. And particularly in the attic space where you're going to be blowing it in, there's a gap where the baffle rests against the roof deck, and then the top of the wall, is sort of down here somewhere. So you have this gap of vertical space between the two. Well, if you can imagine coming in there to blow insulation, if that gap remains open, then you're just going to clog up your soffits, and you can't do that. Well, the standard approach to that issue is to just take a chunk of fiberglass bat and stuff it into that gap, which is just fine if all you're trying to do is keep the blown-in insulation out of the soffit. But we cared about more than just that here, because there's an effect called wind washing that can happen with fluffy insulation that leads to a condition that's known as cold corners. But basically it's like this. Air can flow right through insulation fibers. Insulation is not airtight, never has been, never asks to be, never will be. So you have to provide your air tightness through other means when you're using fluffy stuff. Okay, well, what does that have to do with our attic? Well, the air coming in through that soffit vent is going to mostly go through that ventilation baffle, but with nothing but bare fiberglass right here at the base of it, some of that air is going to go through the insulation as well. If that air is cold enough, it's going to actually almost negate the thermal resistance of that insulation because the insulation itself is going to get cold, okay? Well, we solved that by instead using a little piece of rigid styrofoam board in that vertical gap that's sealed into place using canned foam. And by doing that, we force 100% of the air coming in through that soffit vent to go up through that ventilation baffle so that none of it has any opportunity to chill the insulation at the edges of our roof by traveling through it. And that's going to eliminate that wind washing and eliminate that cold corner out at the edges of those affected rooms. So let's see. I think that's all that really needs to be said about the insulation approach here. Hopefully, you've kind of clued into some of the extra little details that we put in. Ultimately, insulation is the kind of thing that if you've got your air barrier right and your mechanicals right, you basically just need to make sure that the insulation is present and well installed, and the building's going to work just fine. And so that's what we tried to do here. The particular product names, if you care to know them, are, like I said in the crawl space, that rigid foam is Halo Interra, and that is the FR variant of that. That just means that it has a fire retardant property that allows it to remain exposed in a crawl space application, as opposed to, say, requiring a fireproof coating like you would have to do with closed cell spray foam. And then all of the fiberglass bat product is called Knauf EcoBat. That's K-N-A-U-F. They're a German company with manufacturing here in the US. The product line is EcoBat. You can look that up. It's got a Green Guard Gold certification for indoor air quality. Very, very good stuff. And the blown-in insulation in the attic is CertainTeed InsulSafe. And you can look that up as well if you want to learn more about that. I want to take one moment too and just emphasize that we were able to get a really well insulated and airtight house without the use of any spray foam. And that mattered to us here because, in my view, there's a lot of unanswered questions about the long-term effects of spray foam houses on the occupants, that long-term exposure. And even though the foam industry will say that once the foam is cured, all the off-gassing is complete and it's totally safe, I think there's plenty of reason to believe that. But what concerns me about that product is that it's manufactured as it flies through the air on a job site. It's just the nature of the system. And to me, it seems very hard, if not impossible, to guarantee the level of quality control that you would need for a product that has the potential to go very wrong. And, so mixing ratios, temperatures of the chemicals, temperatures of the hose and the gun and the air and the substrate that the foam is being applied to, all of these play into a proper cure. And that's just a lot of variables to contend with when you're installing it. And so all that to say, we definitely feel that there are places where nothing else will work other than spray foam, and I think it's a great solution for those times. But whenever you have an opportunity to use something else, I always counsel people to take that opportunity and keep as much foam out of the building as you can. And that's what we did here. And I think we did it really well, and I think the results speak for themselves. So if you have any more questions about any of that stuff, feel free to reach out. The contact information for myself and my partner is right over here on the kitchen island sign. If you're here taking a tour, you can grab that and, or don't take the sign, but grab the information that is, and get in touch with us if you want. Thanks again for checking out this video and for checking out this house. We hope you enjoy the rest of the series. Thanks for watching.